Sounds good. All right, let's do it. Welcome, everyone. Thanks for joining us today. We want to highlight a few items as we get started. First of all, as attendees on today's webinar, your camera is going to be off and everyone's going to be muted. But if you do have any questions, you can use the Q&A tab at the bottom of your Zoom. It should be pretty easy to find, and you can enter any questions you have there. At the end of today's session, we are going to do a Q&A, and we'll address any questions that folks have at that time. And we're also going to be recording this presentation today, and we're going to make it available when it's ready, probably within about a week or so. If you hear or see anything from our panelists today you'd like more information about, feel free to send us an email, and we can set up a one-on-one call to discuss more. Of course, we're available to answer any questions. But the reason we're all here today is because we're going to provide you all with a fresh take on demand response in retail grocery in 2022. So let's start by introducing our panelists. My name is Amrit. I'm the co-founder and CEO of Axiom Cloud. I've been developing and commercializing new tech for retail grocery for about 10 years now. Axiom Cloud, our current company, is bringing cloud analytics and automation to refrigeration in retail grocery. And of course, we'll talk a lot more about that today, what that looks like. James McPhail is the founder and CEO of Enersponse. So James is an expert in distributed energy resources and demand response. And over the past 20 years, he's also had the fortune of working with N-Cycle Energy, Enerdoc, Energy Logic, and Zen Ecosystems. James' industry passion is automated demand response and partnering with other industry leaders to drive the automation of distributed energy resources. We also have Kurt Knapke, who is a VP of Solution Strategy for the cold chain at Emerson Commercial and Residential Solutions. So Emerson Commercial Residential Solutions offers industry-leading products, systems, and services to create comfortable, controllable environments. And Kurt has been with Emerson for 25 years. During which time he's developed deep expertise in retail grocery and the cold chain. And finally, we have Max Halik, who is a product developer on National Grid's commercial energy management team. National Grid is an electric utility serving more than 20 million people in the Northeast, whose goal is to transform the electricity and natural gas networks with smarter, cleaner, and more resilient energy solutions. On the commercial energy management team, Max works to find and implement innovative solutions that make commercial buildings like grocery stores and supermarkets more energy efficient and flexible. So that's all the reading I plan to do today. The rest of today's discussion is going to be exactly that. It's going to be a discussion. And so I'm going to do less talking, and I'm going to be asking a lot of questions of our panelists. The whole point is not to hear me drone on, it's to hear a bunch of different perspectives about how DR is changing and why it's worth a fresh look in 2022, especially for retail grocery chains, because there have been some pretty big changes. So with that, Turner, let's go to our next slide here, the agenda. So this is a pretty simple agenda. In broad strokes, we're going to talk about these four main topics. First of all, what is demand response and how much revenue can be generated? That's always the first question. And then the second question, why isn't DR more widespread, DR demand response? Why is participation not more widespread? Third, what has changed in recent years? And fourth, we're going to talk about some program and technology examples to make this a little bit more concrete for folks. And then finally, we'll end with the Q&A portion, of course. So with that, let's talk about the demand response ecosystem and let our panelists start speaking up a little bit here. So you can see this circle basically on the left-hand side of the screen right now that talks about the overall ecosystem and the various players that participate in demand response and make it possible. And so maybe we should start at the highest level. And this is a question for Max with National Grid. And that question is, why does DR exist and how does it help the utility?
Great question. And I'll speak to the sort of the high level broad strokes because we're sort of at the beginning and at the end of the cycle. The concept is real simple, and I'm sure some of the folks on today's webinar have some familiarity with the fact that not all electricity costs the same. It's just simple supply and demand. When lots of people want to use electricity, such as on a summer evening, we as utility pay a premium to generators to meet that peak load. Not only that, but those peak events tend to be some of the dirtiest electricity on our grid. So that presents a problem for us in a couple ways. Really, for decades, utilities have worked to reduce that impact. Demand response started off with utilities just, paging large commercial customers to manually turn off loads. Usually those are part of, specific discounted electric rate structures, tariffs. Eventually, over the course of these last 2 decades, we've gotten to the point where we're just paying customers for each kilowatt that they reduce their building's load by during times of those system peak events. For each kilowatt that you turn off, we save a few $100. And so we set up a program where we basically pay a piece of that, or more accurately, we offer a payment to the whole ecosystem of products and providers that has developed to support this system. Maybe that's a segue for what the other folks can speak to on the panel.
Well, Max, one thing that, the way that I think about DR in like the most simplistic terms, and, tell me if I'm wrong here, basically when the grid's under a lot of stress and there's more demand, and it looks like demand might outstrip supply, essentially National Grid will send out an SOS signal and say, hey, we need some help. We need you guys to help us relieve stress on the grid, and we'll pay you for that. Is that a fair or super simple summary?
Yes, I think that's a great summary. Usually with sufficient notice. So, we're not typically saying, the minute that we see things start to spiral. For us, it tends to be day ahead notice. And that call will percolate through, a few layers of third parties who then tend to work with those customers. Sometimes that call is more of an automated response in certain parts of the country. But yeah, that's a great description.
Cool. So yeah, that's a good segue to James with Enersponse. So after National Grid puts out this call for help to help, relieve stress on the grid and pay folks for that, this demand response signal, what does this DR ecosystem look like? And I guess maybe from your vantage point, James, what is Enersponse's role? And then, maybe you can kind of give an overview of the rest of the ecosystem and how you guys are participating as a DR aggregator.
Sure. Yeah, I think that's a great segue, because it's pretty typical that when when National Grid is calling for one of these grid reductions, that there's typically other utilities that are also calling for reductions at those same times, or even at the larger market operator level. So where Enersponse comes in is we get to work with folks, not just National Grid, but the other utilities out there in the space, or the independent system operators, and even some of these other programs to where it's more like reserves markets, and we even go as far as taking price signals directly off of day ahead and day of markets, so that we can turn all of those things into those similar SOS signals, right? And some of those are with a good notice, a day's ahead notice, but some of them are really close to real time. It could be as little as like a 10-minute notice. So what we've done is we've built our platform in a way to where we get to take all these different types of communication. Luckily, there's no pagers out there these days, but we take these emails, and we take sometimes there's an automated signal that comes from a utility, or sometimes it's just us looking at the price of the market, and then we're turning these into really simple signals so that we can then relay those and really translate those into actionable items, so that our customers can participate using the controls that they have in place, like Axiom, like Emerson. So where we come in is really just taking those market signals, those market things, be it DR programs or other drivers, and then turning those into actionable items. And the important part about that is there's what we do as a demand response provider is we take these different types of programs and make them digestible for different customer segments. Because what a supermarket can do is much different than what a large manufacturer can do, right? There's different barriers, there's different conditions. So we really take the time to make those bite size and to move those bite size elements downstream through folks like you all.
So I'll do the same thing I did for Max, which is dramatically and grossly oversimplify our whole business. And tell me if I'm wrong here. So you guys are going out and you are buying flexible capacity from all kinds of different buildings throughout a region. The ability to shed load on demand, and then you're aggregating all that into your platform, kind of like a marketplace almost. And then you're essentially selling that flexible load to the utility when they send out these SOS signals almost. Is that fair?
Yeah, I'm going to put that on a slide.
Nice. Okay, and then the other question for you quickly, James, I guess, is in reference to this map on the right-hand side of the slide, where are DR programs available today, and kind of how do you see that changing in the near future?
Yeah, so the states that are shaded here are kind of your more traditional program areas. But there's also programs that exist where typically demand response providers or aggregators wouldn't operate. For example, we don't have the state of Washington or Oregon or Nevada highlighted here, but there are utility specific programs in each one of those markets to where similarly, we take that signal and we pass it through to our customers that have fleets of buildings nationally. Because we can't monetize a program doesn't mean we're not going to help a customer earn money in a program there. So Nevada, you have Nevada Energy has a great program. The monies don't come from us in that scenario. The monies go directly from Nevada Energy to the customer. But again, we're able to take our platform and automate that signal so that customers are able to earn more. So there's certainly pockets within these states that are not shaded. And then, I mean, it's not every state, but most states have something. It's just not really the entirety of those states. But there's also rulings that will open up more of the Midwest and some of the Southeast. To incorporate more distributed energy resources as we get to kind of evolve into having more dispatchable resources in the market and smaller resources. So the map is certainly growing, not shrinking.
Yeah, the map also doesn't show our neighbors to the north. We're working with some of the largest grocers up there, and the DR opportunities in Canada are just fantastic as well. So that's not shown here, but important to keep in mind. So next up on our list here is Axiom. So basically, I'll speak on behalf of Axiom here. So cloud analytics, so we are we're not replacing building controls. Instead, what Axiom and other cloud analytics companies do is supplement those building controls. Whereas building controls are focusing on minute-to-minute, second-to-second control of equipment within a building to achieve really specific goals. Maybe that's, product temperature or occupant comfort, or light levels or things like that. In contrast, cloud analytics are zooming out and instead focusing on optimizing the economic performance of the building and also in many cases portfolios of buildings as a whole. And so cloud analytics are using data from the building controls and then all kinds of other external data sources such as ambient weather conditions, future weather forecasts that are predicted, grid stress levels, based on signals from James and other folks, historical building performance, et cetera, and a lot of really advanced modeling to predict how the building is going to perform in the future and then optimize against those predictions. So not a replacement for building controls is kind of the summary there. In the case of demand response, cloud analytics is really valuable because it helps to kind of identify the best opportunities to maximize load reductions without negatively impacting any of the other factors that these buildings require, like in the example of refrigeration, product temperatures. So that is this portion, kind of the third box here. From there, let's go to Kurt. So Kurt at Emerson. Kurt, can you talk about Emerson's experience with demand response in the past, and also, I guess, more generally, giving a quick overview of Emerson and your role in grocery stores?
Amrit, as you mentioned earlier, Emerson's a leading controls provider to food retail and other portions of the cold chain, whether that be the food cold chain or the vaccine cold chain or many of the other cold chains that exist throughout our logistics systems today across our country. Where our strength has been, we've always been, have a core strength in refrigeration and the peripheral other ecosystems in the building itself, whether that be the lighting or the comfort control HVAC systems that are there. Emerson's past experience, we've had over the years multiple DR participations throughout the country. It seems like it changes over time depending on the geographic region that we have on the right hand of this slide, or what's going on in the economy at that time. So incentives go up and down, the participation dollars that are available are changing over time. So that has always changed the economics around the participation for demand response. But I think some of the other things that's more to the core of what's working for demand response right now is historically how people have looked at demand response and how they've chosen to take actions with that is more of a static rule-based decisions on demand response. So when they get either a manual DR event or even an auto DR event, they'll make decisions to say, look, no matter what, I can give up this much and I'll be safe across all conditions. With the evolution of the predictive modeling and the optimization that you talked about from Axiom, we can be more aggressive on the demand that we're actually shedding and the overall response that we can have to the ecosystem of utilities and the generation and the value of this, both to utility provider and the end users.
Thanks, Kurt. Super helpful. And for anyone who doesn't know, in a lot of grocery stores, over half the grocery stores in the US, correct me if I'm wrong, Emerson controls are basically controlling all the refrigeration, all the HVAC, and all the lighting kind of throughout the store. These guys are deep into grocery, for anyone who doesn't already know that. So with that, let's go to our next slide, and we're excited to do a poll. So to kick things off here, in order to be successful with demand response, zooming way out, even from grocery, just broadly, there's kind of 4 things you need to be able to do. Number 1, you have to be able to shed a significant amount of power, right? That's the whole purpose of demand response. Number 2, you have to do it for an appropriate length of time. In many cases, that's multiple hours. If you're not doing it long enough, then the overall value you're generating is going to be significantly reduced. Number 3, demand response cannot negatively impact operations. And this, people have learned this the hard way over and over again. If you're too aggressive with demand response and it's generating negative impacts to operations, it's not sustainable. And how you generate value on this is by figuring out a solution that's sustainable, that you can do it over and over and over again over time. And number 4, you can't increase your electricity bills. So what is the phrase? You robbed Peter to pay Mary or something like that. Basically, if you are generating a whole bunch of demand response revenue, but at the same time, you're causing electricity bills to spike, then, what's the point? At the end of the day, it's all about dollars to the bottom line. And so there's no point in just creating a bunch of savings over here and then, generating a whole bunch of additional costs in a different area of your P&L. So this is how we think about demand response. In order to be successful, you have to be able to do all 4 of these things at once. And so, Turner, why don't you turn on the poll? Because we're really interested in understanding for audience members, folks here today, what is your perception of kind of what are the largest challenges that for demand response for retail grocery, or what have those been historically? So you should see a poll that is popping up on your screen right now. And so we're going to be quiet and give you guys a little bit of time to read through this. And this is a multiple choice. You can choose more than one answer here. So yeah, go ahead.
looks like answers have stopped rolling in so quickly. So
Yeah, we're seeing a fantastical response. Thanks everybody for being so engaged. Seems like folks are actually paying attention and not checking their emails. That's great. So yeah, you can continue to answer here. We'll give you another 10 seconds or so for anyone who's still thinking. All right, give it 3 more seconds. Nice, I saw a couple of folks squeeze in right into the wire there. That's great. So Turner, can you now share our results? Let's see here. Are people able to see those results that Turner's sharing? For some reason, I'm not seeing them.
I could also pull them up on my screen.
Okay, somebody just said, yep, they see them. Very good. Thanks, Jason, for that feedback. All right, so really interesting. We're very split across these various categories, but there is one that rises higher than all the rest, and that's food temperature and safety concerns. And so I think that that's a really valid concern. The other two that seem to be quite high are program availability and then impact to store operations, basically too much manual effort. And so given that feedback, let's see here. I'm going to get back to our screen. So based on those poll results, let's discuss the most common pitfalls and challenges first. So food temperature and safety concerns. It's really interesting to hear folks bring that one up because historically, Kurt and James would love to hear your thoughts on this, but historically there has not been a lot of, folks have been primarily focused on HVAC and lighting for demand response and retail grocery and less so on the refrigeration side. Do you guys agree with that statement?
Completely, Amrit. I think it's looking at the liability associated with demand response. You can take action on lighting or comfort systems more liberally and take on less risk than you can with the refrigeration system itself.
Yeah. What are some of those risks when it comes to load shedding on refrigeration, Kurt?
I mean, ultimately, you're looking for reduced food product quality, actually creating additional shrink throughout the store from the regulation from the temperatures that must be maintained with that temperature, as well as potentially even a product loss. So.
And it doesn't matter how much money you're saving on energy. If any of those things happen, it's not going to last. And then James, on your side, from your vantage point, do you agree with the fact that folks have not been focusing on refrigeration quite as much as HVAC and lighting?
Yeah, which is unfortunate because there's so much load intensity behind the refrigeration. But as Kurt said, it's comfort is you're there, you're in it. You can set cooling set points, adjust them by a couple degrees. So it's kind of the low-hanging fruit. Lighting now with LEDs, it's not nearly as much of an impact as it had been historically. So the next obvious place for demand response to go is into refrigeration. But yeah, for exactly those reasons, it's a massive concern, and it becomes even more of a concern when people don't have proper monitoring in place to be able to watch those temp cases and to react accordingly. So yeah, I think it's spot on.
So kind of the set it and forget it strategy that works for lighting and HVAC, just a little bit too risky for refrigeration is kind of what I'm hearing. Yeah,
and there are some folks that participate with refrigeration and that they've figured out kind of what their limitations are. But even at that, those are barely scratching the surface because they want to maintain such a buffer in there to make sure they don't fall into that risk category. Yep, makes total sense. You can't upset the food safety or the merchandising folks. That's a non-starter.
Okay, the other ones that got a lot of attention or a lot of responses were impacts to store operations. So too much manual effort. And I think this probably harkens back to the days when, there were pagers involved or there were phone calls involved and, the internock days, in the early days of DR. Max, I see you nodding. Any thoughts on this?
Yeah, I think, we see the same sorts of trends that James and Kurt have outlined. Plenty of HVAC loads being sort of the most typical common customer participating. And though I guess it's also worth noting that by total KW participating, it probably actually goes to manufacturing process loads. But the classic, the usual suspect is, big box retail, healthcare, educational, a little bit of grocery, but doing that, set it and forget it. You can do that. The cooling control, save a bit of KW that way. Lighting has essentially vanished from our perspective because LEDs are so widespread, particularly in the Northeast. But I put it down to the technology infrastructure that's enabling control of those assets. That's how our DR programs evolved. We responded to the market's ability to enable those sorts of set point control to respond to the developments in smart thermostats, BMS. It's easier to do it in HVAC because we have that enabling technology infrastructure, and it just makes sense to get paid for that ease, and that really minimizes that operational impact, I think.
Makes sense. The other one that got some votes was program availability. And so, James, do you think that's more a function of kind of what DRs looked like in the past, or do you feel like that's still a major barrier for especially national retail grocers?
Yeah, it's probably a bit of both. Some of it, the way I would interpret it, and this is some of it is probably coming from the programs that had historically been available or longer duration programs and hard to participate in. So I'm actually at the EEI key accounts workshop this week, and I remember it was about 3 years ago. One of the largest U.S. supermarkets actually had a panel on other ways to impact demand without having to participate in difficult demand response programs. And that really highlighted for me that a shift that needed to take place because demand response programs were getting called, where I live in Southern California, the programs got to where they were being called 6 hours long every single time because there weren't a lot of program options. So that causes fatigue. It really, on top of fatigue, when a typical HVAC set point adjustment, or even if you get into some playing with some suction pressure, you're not going to do well over a 6 hour long event. And if you're not going to do well over a 6 hour long event, then you're not going to get paid because you didn't hit the participation levels. So, I think that's one of the things that's companies like ourselves have been able to go out there and kind of recreate programs that are, like I said earlier, more digestible, so that instead of we're going to put you in a program that gets called 6 hours long, we can say, hey, we will cap your participation at 2 hours long, maybe 3 hours long, 4. And basically we kind of build the program around the participants' ability. And for supermarkets, we find that 2 hour to 4 hour max is really the sweet spot. So I think that's probably one of the elements of program availability. The other element is that there haven't, there's been limitations because companies like ours have required a minimum amount of load to be shed. And if customers weren't able to shed anywhere from 50 to 100 kW, then our competitors really have typically steered away from enrolling those types of customers. So we just take a different view on it, which is let's not go install metering. Let's not go install additional pieces of hardware. Let's send software signals to what you already have in place, like with Axiom, like with Emerson, to be able to automate those things. That takes a big cost out of the equation so that we don't have to have minimums, right? So that not only can we go to the supermarkets that can only drop 25 or 30 kW, but we can go even further downstream to the corner stores and the gas stations. So I think both of those things are probably what's sitting behind program availability, but those are things that are certainly being addressed really in a meaningful way, especially over the last 2 years here.
Yeah, well put, James. I think there's one here that didn't get as much attention as I had hoped, and that's increasing energy bills due to demand spikes. Just really quickly on that, I want to hammer on this, that if you're saving, $2,000 or you're generating $2,000 in DR revenue, but you're causing your electricity bill to go up by $3,000 in that same month by causing a big demand spike right after the DR event, then ultimately that's not a success, because total dollars out the door is still going up. Your costs are still going up; they're not going down. So that's one that I think it's a really common pitfall that some folks are falling into, and in some cases it's very difficult to detect. So that's the kind of thing where you may feel like you're generating a whole bunch of DR revenue, but you're not seeing this hidden cost that's a little bit more difficult to detect. So really wanted to hammer on that and make sure that folks are aware of that potential pitfall. So let's keep on rolling here, Turner. What has changed in recent years? And I think that James already talked about a lot of these things, especially the fact that aggregators such as Enersponse have made enrollment much simpler. And rather than trying to squeeze customers into a pre-existing DR box or DR program, James and his team and other folks in the industry are figuring out ways to make the programs more accessible and kind of more molded to the specific characteristics and profiles of their customers. So much more personalized, much more compatible with their business models. But going back to Max here, Max, how have National Grid's DR programs evolved over time to alleviate some of these challenges? And why basically is DR better and easier today than it was in the past?
Sure. Well, at least from our perspective, the Northeast is maybe slightly newer to the game of DR than the West Coast or other parts of the country is. We started with our program is called Connected Solutions. It just started as a basic thermostat DR measure back in 2016. So it was kind of limited to specific products. It now includes both residential and commercial customers. We've since then added more sort of product pathways to participate. So and again, with this narrative of expanding DR based on the expanding technical capability to control loads, we have specific mechanisms and relationships with those product providers to enroll thermostats, to enroll EV chargers, to enroll batteries. That's particularly on the residential side. On the commercial side, I think we've changed, and this is I think a pretty standard approach, that we're fairly agnostic as to what participates. From the utility side, we don't have as many levers to pull to incentivize behavior as folks like Enersponse might have in working directly with the customer. We're agnostic as to the types of customer load that come into the program. And we're just constantly trying to look to make participation easier, particularly through increasing incentive to make sure that that's matching with like the current market conditions and how much we value KW. The group that I work with in particular, National Grid, is constantly looking for, what new technologies that enable that. Can we incentivize? Can we pay more for a customer to upgrade their BMS, to upgrade this piece of the ecosystem? That's one of the other levers that we can pull.
More incentives, more dollars for KW, and kind of broader, simpler enrollment is what I'm hearing.
Yeah, and looking at what are the types of loads that are not represented in the mix, and what is the thing that we can incentivize? What is the piece of hardware, software, or the way that we can change the program to bring that into the mix as well?
Makes sense. And then, Max, I don't know if you're kind of prepped to talk about this, but can you talk a little bit about this FERC Order 2222? Feel free to say no.
I'm tempted, though, leave that to folks who might be more familiar with it than I am.
That's fair. Yeah, that's supposedly my talking point, but I don't know much about it either. I guess quickly jumping into that. Basically, grid operators in the US are now required to develop plans to allow distributed energy resources to access wholesale energy markets. And so if I understand correctly what that means, demand response is one of the methods to accomplish that. And so the bottom line is that this is now a federal program. This is something that is happening not only in those states that were highlighted in blue a few slides ago. This is now going to be nationwide in the coming years here. Essentially, these folks, demand response programs are more and more going to be competing head to head with other sources of wholesale energy. So put another way, payments are going up over time. Do you think that's a fair summary, Max?
I think so. I mean, I've tracked some of the FERC rulings that have, paved the way for energy storage to come in more broadly to participate in wholesale markets. I think that we have to consider that, considering how these programs are run at a federal level is very different from those regional offers. The local incentives, I think, might be a bit clearer, and we'll see how this actually pencils out into translating the opportunity here for things to participate and the federal mandate for things to participate versus how where the money comes from. But yeah, I wish I could comment more on this, but I think it's going to take a while to trickle down to mean anything meaningful at the local
That's
level.
fair.
Yeah, and with that, I mean, the wins here on that FERC order is that demand response, being included as a distributed energy resource, but two, just a quick example, a lot of the so we have about 15,000 sites connected to our platform nationally, and there's of the customers that we work with, we typically can only address about 60-ish% of their locations with demand response programs on the market. So what this ruling does is it'll actually open more of that up in markets that don't currently have programs publicly available. So it's going to take time because the order came out and there were two large players that said, all right, we need time to figure this out. But in general, it should open up more of that program availability. So maybe folks that only have locations in the Southeast or in the Midwest, that there's now a path to programs in the near future.
Thanks a lot, James. And then switching gears a little bit, Kurt, obviously, the last two items here, incentives decreasing the cost of new technology and cloud analytics, unlocking refrigeration. Thinking about the technology side of things, there've also been some major changes in the last couple of years. And so I'm wondering, from your perspective, what advances in technology have we seen that can get grocers comfortable with leveraging refrigeration for increased load flexibility?
Yeah, Amrit, I'll start first with the evolution of the utility providers and how they're now using more complex methods to actually charge based on the usage, whether that's flat rate, peak rates, automatic pricing or on-demand pricing. I think that is increasing the opportunity to participate more in demand response. Also, the increase in the incentives available to establish the controllers and the ecosystem of information out there, as well as the participation dollars going up. I think over time, the decreased cost of this technology and creating a base of where all the stores, there's more and more connectivity amongst these facilities, more and more data that's being flowed through, And it's creating the opportunity to actually start to get smarter about how we actually deploy this type of an event, and actually predicting the risk on these type of events. So as James mentioned, participating in a larger group and taking actions in a shorter period of time, understanding exactly what our risk amount is, it provides more operation to smooth out the risk so that one retailer is not taking a huge liability in their food safety by the static demand and response rules that exist, and having more dynamic rules established by cloud analytics and leveraging the digital twins that we have now for refrigeration systems, and having the fact that it's connected and we can actually monitor the impact on the food temperature up into various thresholds that we can set, has become a lot more availability on actually making some demand response actions on the refrigeration system itself.
Yeah, thanks a lot, Kurt. Yeah, for this last point here, I'll add, essentially refrigeration, like we talked about earlier, for a variety of different reasons, has been overlooked as a real opportunity for demand response. But when we're talking about 40,000 grocery stores in the US, another 10 or 15,000 in Canada, and then, massive refrigeration systems, typically on average, anywhere from 50 to 150 kilowatts worth of refrigeration load on each one of those, that's a huge opportunity for the grid. And so the opportunity here to essentially use cloud analytics to move away from the set it and forget it mentality into something more like Kurt was saying, where we're modeling, we're predicting, we're optimizing against, historical performance, for example, and then dynamically making changes, duty cycling valves, duty cycling compressors, changing set points in real time, responding to changing conditions in the facility. So if a door is left open, okay, we have to send more cooling to that case right now, for example. That, when we're getting to that level of granularity and automation and intelligence and optimization, that's what enables us to essentially take larger bites out of refrigeration load in a way that is where we're mitigating risk appropriately. And the risks that we talked about earlier with, food temperature, food safety, food spoilage, those are the types of risks that have to remain top of mind when we're taking these new strategies. But that's where the data analytics and the optimization and the automation come in. We're moving away from this idea of, hey, on the hottest day of the year, let's make all of our food warmer. Nobody wants that, and there's not a lot of opportunity to do a lot of load reduction in that with that type of optimization. So we're taking a very, very different approach now with cloud analytics to unlock refrigeration and really truly deepen the amount of demand response participation that grocery stores in general can have. Zooming all the way out, it's really important to remember that refrigeration accounts for anywhere from 50 to 65% of all energy consumption in a typical grocery store. So that's the elephant in the room. We can twiddle with lighting and HVAC all day, but ultimately, if we want to really address demand response in grocery, it comes down to refrigeration. So does all of this mean that it's time to reevaluate demand response? Let's go to the next slide, Turner. So let's talk about a couple of example demand response programs. So in this table, you can see, three specific programs in California, Massachusetts, and Texas, with very different parameters, very different payments, very different structures. So, and then at the bottom here, we'll talk about this particular example. In fact, maybe I'll talk about it right now. Essentially, what you're looking at here is a 24-hour period for 4 grocery stores where we stacked up the load profile for 4 grocery stores. And the y-axis is kilowatts, the x-axis is hours. And essentially, what you're looking at here is, the green line is the actual measured building power consumption, and the blue line is the modeled building power consumption. And so the difference between those lines, when the green's higher than the blue, that means that that building is pre-cooling its refrigeration. In other words, it's charging and preparing for a load shed event. And then when the lines flip, when the green line is lower than the blue, that means that the building is in load shed mode, and the refrigeration suddenly is consuming substantially less power than it would be if it was not being, in load shed mode. And so that in this particular case, we demonstrated 193 kilowatts of flexible capacity, or essentially, it would have been 193 kilowatts for any of these 3 programs shown across 4 stores for that period of time. using only refrigeration in this case. So just giving a sense of, how big the opportunity can be. So going back up to the chart at the top here, this is a question for James. What kinds of customers can succeed in California and Texas? And then do you want to talk a little bit about, how often events are called, what types of requirements customers face, et cetera?
Yeah, so it's interesting, right? Because we're kind of covering a pretty good spectrum here. But like in California here, California is a great example of just how different the programs can be across the state, because we're showing the capacity bidding program here related to the Pacific Gas and Electric program, which is great. But when you look at the capacity bidding program in Southern California Edison, it gets called more like 30 to 40 times a year. So it really comes down to that program selection. If within California, there's probably 4 different programs one fleet would participate in across the different utilities in California. They're going to vary. And the reason they'll vary is because in Pacific Gas and Electric, fine, we can get 1 to 4 hour long events and 8 a year. That's not bad, right? That's something that most grocers would be able to live with. But 30 to 40 events a year, it still isn't bad. But if they're all 4, 5, 6 hours long, then that's going to be really difficult. So we have other program options like DRAM, or there's participating in the resource adequacy market. So there's a lot of different options so that we can basically mirror that top line capacity bidding program and limit to that 1 to 4 hours. But I think the important part there is there's complexity. There's a lot of different options that exist behind there. But that's really where we come in, is to say, we're going to filter out all these other options, and we're going to bring these to the top, because these are what fit. These are really what back into what you're technically able to do. I think it's great to show the daily dispatch program, right? And I'll let Max talk to that more. But just going down to Texas, that event length of 15 to 30 minutes in ERCOT, those events can be much longer. But the key here is that capacity bidding program gives you a day's notice, right? You have time to plan for that. That emergency response service in Texas, you only get a 30-minute notice. So it really has to be automated. You have to have that automation in place, because you can't do that by playing telephone, right? I think when you kind of look at it and say, you could do those California programs with a day ahead notice and manually. When you get into that ERS program, you could potentially do that manually, but really want automation. But something like daily dispatch, you want that automation. And I'll stop there. I'll let Max talk to that, since it's his program. But when you get to that level, I mean, you see it. It's just some massive opportunity in the dollars.
One thing that James does, which Enersponse does, which I also think is really good, is beyond just helping customers select the best programs that are most appropriate to their needs. Enersponse also uses this portfolio strategy, where they're taking a variety of different customers and kind of, putting them all together in a group, in a portfolio. And then, maybe some folks can only provide an hour or 2 hours, and, maybe you can pair up 2 of them, and those 2 together can then do a 4-hour event, for example. And that portfolio strategy, I think, just adds an additional degree of flexibility that makes this so much more possible for a broader set of folks, and especially retail grocers. Max, any really quick comments on this slide? Sorry, I'm forging ahead to make sure that we have time for Q&A.
No, that sounds great. I think James has covered a lot of it, and really, Enersponse is the entity to look at for doing flexible participation of sites. From our perspective, daily dispatch is just one of those offerings. It's a pretty robust offering. It can actually, the incentive can actually be as high as $300 per kilowatt in Rhode Island. The events, that actually would probably be a lower year. I think last year we might have had about 25 events, but we say that it could be higher, maybe as much as that 50 range. But you know, our program is also 24-hour notice. So you will have plenty of notice to participate in the program. The types of loads that can work with that 24-hour notice, it depends on what you have built to do that automation. It's maybe easier to do that in manual set point adjustment with HVAC loads than with other loads. But from our perspective, you know, it's if the question is what is best suited for the program, we're agnostic, and we're trying to look for ways that we can enable diverse loads and incentivize new things to come into the portfolio.
Awesome. Thanks, Max. So Turner, let's jump to Q&A.
Yeah, great. Got some really good questions here. We'll try to get to at least a few of them. Really quick, that was asked prior to this last slide, but somebody asked, what kind of money are we talking about here for stores? So I think overall, I don't know, maybe Amrit or James would be the best to tackle that one. You know, we showed the raw dollars per kilowatt numbers on the previous slide, but maybe somebody could give an estimate of the total value available.
Well, you know, we're working, I guess, publicly with at least two companies, two major grocers. And so, you know, for smaller stores, such as Grocery Outlet, you know, some of those stores have, you know, as little as, 18 kilowatts of load, but up to 30 or 35. And then for, you know, the other public customer that I can talk about today is Whole Foods. Those folks have larger stores. I guess some are medium, some are large, but we're talking anywhere from, 25 to 60 kW per store of refrigeration load that's shuttable. Again, in a very, very responsible and safe way. And so, if you're looking at $50 or $60 a kW, it's a nice amount of revenue if you can do that in a low cost way. I don't have the numbers off the top of my head.
Great. And then another question, maybe I'll direct this one at James and or Max. Are there some resources to find out more about DR programs in my store areas? Do you recommend going to individual utilities, or is that information aggregated somewhere?
Well, I'll just speak very quickly. The programs, how they're structured and how participation work is going to really depend on the utility in question. I'd recommend reaching out to your utility, or if you have a contact within that utility's energy efficiency or DR programs and an energy manager that works with your utility, that's probably the best way.
Yeah, and we actually we try to take some of that that lift off of because it's even just explaining that, right? You think if you have a fleet of buildings across the country, that's a lot of conversations. Some areas you might have better engagement with a utility rep or program management than others. So what we've done is we've actually created a tool to where we can take a list of thousands of sites. We run that through our tool, and we actually put in the parameters. So we say no programs beyond 4 hours long, or no programs with less than a 30-minute notice. We put these parameters in, and we're actually able to generate an entire report for you in about 15 minutes that'll show you the hundreds of programs that your thousands of sites could participate in. And we actually quantify those similar to the numbers you're putting out there, Amrit, which is 25 to 35 kW per store, and depending on the size of the store. And it not only gives what the annual revenue potential would be for those programs, but it also shows where there would be different types of controls incentives, like in California, to where if there's, let's say there's $2,000 a year in demand response revenues per store in California. Well, there could be $6,000 to $8,000 in controls rebates for that store that could be spent on an Axiom deployment, or it could be spent on upgrading E2 Emerson controllers to E3s. And so we really just try to paint that entire picture to make it a little easier.
Yeah, I'm actually want to extend that even a little bit further, James. You know, when we're looking at grocery stores and looking at implementing demand flexibility, demand response is, you know, something that can generate some really nice new revenue, you know, maybe $3,000 a store or something like that. In addition to that, using that same exact type of operation with demand flexibility, we can typically generate another 10,000 or more in energy bill savings by managing peak demand charges on a dynamic basis. And so I think it's really important to keep this all in context. You know, this is a really great revenue stream. It helps a broader project to succeed, whether that's moving, you know, demand response across many stores or within a single store, combining demand response with a bunch of other measures. And yeah, this can be really accretive and valuable to help a larger project, whether it's deeper within one store or across a portfolio of stores, to be even more profitable, if that makes sense.
Great, and we've maybe time for one more really quickly, something that could probably be its own webinar altogether, and we purposefully avoided today to kind of try to stay out of the weeds a little bit, but how do baselines work in demand response? How do those get set? Maybe Amrit, you could take 30 seconds, James, maybe another 30, and then we'll have to wrap up.
So measurement and verification is, for these demand response programs, the core of it is typically a baselining methodology. So making an estimate of how much would this building have been consuming if we were not taking any DR measures, if we were not making any changes to the building. And so oftentimes they're using very simplistic methodologies like a 10 and 10 baseline, for example, which by the way is extremely unfair to buildings with large thermal loads such as retail grocery. We're not going to get into that unfairness, and you know, we're not going to ask you to write your ISO numbers today, but the cards are stacked a little bit against retail grocery. I want to be very upfront about that because of this baselining methodology. This is a very prescriptive methodology that utilities are doing and their contractors. It's not something that Axiom or Emerson or Enersponse does. It's a very prescriptive thing that's utilities do, and they have very, very strict rules on that. James, any thoughts on this?
No, I think that's pretty good without getting into the weeds. I mean, there's multiple baselines in various geographies, and some more favorable than others, absolutely. But I think to your point, there's a lot of work being done at the regulatory level to get baseline either adjustments or baselines created that help show for the participation when folks are able to respond to those grid signals.
So that's our time, folks. Thank you so much for coming and participating and answering the poll and asking great questions. If you have additional questions, feel free to reach out to us via email. We'd love to hear from you, and you know, we can set up a call if that would be valuable with any of our panelists. The recordings will be emailed out to all registrants in the coming weeks. And yeah, again, thank you very much and have a great day.